Hello everyone. In this video, I will go over the solution for this question. This question asks us to find the equation in general form of a line tangent to the curve y equal to the square root of 10x minus 59 with a slope equal to 5. As I sketch the graph of y equal to the square root of 10x minus 59, it is the parabola open to the side, as presented on this graph. Alright, on the positive part of the quadrant 1, on the positive part of x and y. Because of the square root here, that we cannot have the negative underneath the square root. So that's why when we sketch this, we could only see the portion of this graph of the parabolas open to the side. Okay, the next step is we are talking about the line tangent to the curve. So a line is a linear equation and it is in general form. So I just want to remind everyone that a general form of a linear equation is given as ax plus by plus c equal to 0, where a, b, and c are integers. Alright, so the key to solve this question here is tangent to the curve and with slope equal to 5. So the definition of the slope is this, okay, dy over dx, or the chain in y divided by the chain in x, or rise over run. So in this case, we should find the derivative of this function. Okay, so I will start off by finding the derivative of y equal to 10x minus 59. So y equal to the square root of 10x minus 59. So I will convert this into the exponential form. So a square root will convert it to the exponent a half. Alright, so I will find the derivative. That means I find dy over dx. So we need to apply the chain rule for this. It means I will take a half, multiply the coefficient in front of this bracket here. So it's an invisible number 1. So half times 1 is a half. So I rewrite the function, and then I rewrite the function. Excuse me, just let me give 10x minus 59. At the same time, I take 1 away from the exponent. So a half minus 1 will give me minus a half. And then I have to multiply by the derivative of what inside the brackets. So the derivative of inside the brackets, derivative of 10x is 10. Derivative of 59 is equal to 0. Right? So after I find the derivative of this function, I'm going to simplify it. So simplify this, I can see that 10 divided by 2, I have 5 left over. So this equation will become 5 of 10x minus 59 raised to the exponent minus a half. Alright, and the question is actually giving me the key that the slope is equal to 5. And according to the definition, the slope of the line tangent to the curve is actually the derivative of this function. So that means dy over dx. And dy over dx is given to me as the slope equal to 5. So what I'm going to do at this point is I'm going to substitute the value of 5 into this equation. Okay, so where is that dy over dx? I will write it as 5 equal to 5, and then 10x minus 59 raised to the exponent negative a half. Okay, so what I'm going to do next is I will move this 5 over to the other side. So 5 divided by 5 equal to, at the same time, I will write it 1 over 10x minus 59 raised to the exponent a half. Okay, so I will bring it down to the bottom to change that to a positive exponent. So on this side, I can see that 5 divided by 5 give me 1. Therefore, this equation will become 1 equal to 1 over 10x minus 59 raised to the exponent a half. And I know that from this equation, I can solve for the unknown x. Alright, I can solve for the unknown x. Okay, so I solve for the unknown x. From the unknown x, I can find the equation of the line tangent to the curve. So for a line tangent to the curve, to find the equation of this line, what I need is okay, so I'm going to review for everyone here. A line is a linear equation. And what you need to have is you need to have a slope and 1 point. Okay, 1 point on this graph, but we just don't know where it is. So we have to find the point. Okay, so the slope we have already, but we have to find 1 point. That means we have to find the value of x and y. Okay, so having the slope of m and the value of x and y as the coordinate of a line tangent to this curve. Line tangent to the curve means the line will touch the curve at only 1 point. And at that 1 point, I can have the coordinate of x and y. With the x and y and the slope, I can find the equation for this tangent. Okay, I can use a point slopes form like this: y minus y1 equal to m x minus x1. All right, okay, so after I find the equation using this point slope form, I can go ahead and convert it into the general form. All right, so that's why after we differentiate, because the slope of the line tangent to the curve is in fact the derivative of this line, of this curve, of this function here. So to find the derivative of this, I got dy over dx is equal to this, and what I do is I substitute the values of the slope. So slope equal to 5, right? So I substitute in here, and I reduce this equation into one unknown, an equation with one unknown, and I'm going to solve for this. Okay, so to solve for this equation, what I will do is I will multiply this over to the other side. Okay, so that means I'm multiplying 10x minus 59 to the exponent a half. To the other side, I multiply by 1. It just itself again, and this equal to 1. In solving for this equation, what you need to do is to get rid of this like square root. Okay, you should square the equation. So it's equivalent to this form here. 10x minus 59 as a square root equal to 1. So what I do is I will square both sides. So if I square both sides, I square a square root, I will get rid of the square root. So it will be 10x minus 59 equal to 1. All right. Okay, so I can put this on the clown here just to remind everyone that I can do this, just keeping this as the exponent a half. Okay, so if I square this, and I have 1 square, right? So I square both sides of the equation. Then you see that you need to multiply these two together. So a half times 2 is 1. So that means I end up with 10x minus 59 to the exponent 1 equal to 1, right? So 1 squared is just 1. So 10x minus 59 equal to 1. So This is the theory behind why we square a square root, we get back to the radicand. So the values in here were just 10x minus 59 to the exponent 1. Okay, so from here, it's so easy for me to solve this equation. So what I'm going to do is I am going to put 10x on this side. So it will be 1 plus 59. Okay, so 10x is equal to 60. So x is equal to 60 divided by 10. So x is equal to 6. Okay, so in this case, x is equal to 6. So in finding that point x and y, I already found x. So how am I going to find the other point? Okay, so the other point, what I have is, take a look at this. Okay, so it's a line tangent to the curve. So that means that point x and y will touch this curve at only one point. And I already have x. That means I can find y by substitute x into this original equation to find the value for y. All right, so I will substitute x equal to 6 into y equal to the square root of 10x minus 59 to find y. All right, so I will have y equal to square root of 10 times 6 minus 59. So that means 10 times 6 is 60 minus 59. Square root of 1 is equal to 1. So the point x and y that I have here is equal to 6 and 1. Okay, so now I'm having a point and a slope equal to 5. Then I can find the equation of this line. Okay, so it's happened to be a tangent line. Okay, it has to be a tangent line because a tangent will touch the curve as only one point. So again, like I reviewed to everyone from previous page, so I go back. Okay, I will use the point slope form. So this is the point slope form. After I use this equation to figure out my equation of the line tangent to the curve, then I could convert it into the general form. Okay, so it will be y minus y1 equal to the slope x minus x1. So y minus 1, okay, equal to 5 of x minus x1, which is 6. All right, okay, so I will multiply this inside the bracket here. I will have 5x minus 30, and I will bring everything to one side of this equation. I will have y minus 1 minus 5x plus 30 equal to 0. So I will have minus 5x, okay, minus 5x, excuse me, plus y plus 29, because it's 1 minus 30. 1 plus 30 minus 1 plus 30 will give me plus 29. Excuse me. So let me take a sip of water before I lose my voice here. All right. So at this point, you can see that I have converted into the form where I have ax plus by plus c equal to 0, which is the general form. And a, b, c are integer. And it is integer. So this should be a 1, but it's invisible. Okay. And 29 is also an integer as well. Alright, so this equation is the equation of the line tangent to the curve as the given point in general form. And I will present to everyone the graph that I have on this page here. Okay, so on this page, what I did was I sketched the graph with the line itself. So in this case, I should have this as y equal to the square root of 10x minus 59. And this line here is the line tangent to this curve at a point 1 and 6. So that's point 1 and 6 is right here. So 1 and 6. And the equation for this one, which we found, is minus 5x plus y plus 29 equal to 0. So this is the equation for this line. Alright. Okay, so this is the equation in general form for this line tangent to this curve. Y equal to square root of 10x minus 59 with a slope of 5. Okay, and it's touched the curve at the given point of 1, 6. And this point here is actually the point that we found. We have to find this point in order to substitute it into the equation y equal to y minus y1 equal to the slope times x minus x1 in order to find the equation for that tangent line. Slope is given to us, and we need to find x1, y1, and we can find x1 by differentiate this equation. And we have dy by dx is actually the value of the slope. Substitute the given slope. We come up with this equation here. We solve for x. After we got x, we substitute into the original equation to solve for y. Now we have a point and a slope, and we can substitute it in and find the equation, and then we convert it into the equation in general form. Okay, so that is the one right there. Okay, but it's actually invisible. We don't need to write that one. I just want to let everybody know so that I want to indicate to everyone that it is an integer. Okay, the value of a, b, and c are integer. All right. Okay, so after I have found the solution, I can demonstrate it by showing you this line tangent to this curve at point 1 over 6. It touches the curve at only one point, and the equation for this line is minus 5x plus y plus 29 equal to 0. All right, thank you.